It's time to talk about 3D toolpaths here. So all the CAM strategies you've done up to this point have been a 2D toolpath. So basically we pulled down this menu here and we picked one of these things, whichever one worked the best for what we were doing. And they worked really well. And you've all been doing fairly well with machining the containers and all the different CAM strategies, the flange quiz, everything. The only problem is the top of our box is going to look more along the lines of something like this, where it's got this lofted kind of funky look. Now, this is just a sample part that we got from Project Lead the Way, so as is this. Again, not terribly difficult to draw or model, but as far as cutting it out of a solid chunk, it can get a little difficult. So I'm going to walk you through what I did here. First thing I did was a setup on this block. And what the setup does is it actually, if I go and edit this, it actually adds extra material. So I would, to make this sort of like, I don't know, ski hill type deal, I would have to start with a block that was bigger. So the block is same size as all the other stuff we've done here, 3 inches wide, 2 inches deep, and 1.5 inches tall. So my setup is good. The next thing I did is something called a 2D adaptive, and I'm gonna actually get out of there, or excuse me, a 3D adaptive, and let me show you what that looks like. So I'm gonna pick a ball end mill, because if I pick a flat mill, you can do that. What's gonna happen if I do that? If I was to do this with a 3/8 flat, I can show you what it looks like. With a 2D toolpath, the tool goes down in the Z and then it does all its X and Y moves, and then it goes down in the Z and does all its X and Y moves. Well, the way this is going to operate is it's going to do X, Y, and Z at the same time, sort of. As a result of that, it will calculate that this tool, if I look at it from the side here, it will figure that this corner isn't going to touch anything that you want to be finished machined. So you're going to end up leaving a lot of extra material, and I'll show you what that looks like. For the geometry tab on a 3D toolpath, I generally don't do anything with it. I just let Fusion figure it out first, and then I'll go back and I'll edit it. With a 2D toolpath, you have to tell it what geometry you want it to cut. You know, what pocket, what profile, what contour, what holes you want to drill, whatever. With a 3D toolpath, you basically tell it the things you kind of don't want it to cut, because it's going to cut everything that it finds inside this yellow box here. So I'm going to just press OK here, press OK, and see what happens. It's going to take a lot longer to generate the toolpaths because it's got a lot more toolpaths to do. So as you can see, there's a lot of up and down motions with this, and a lot of X, Y, and Z at the same time. So let's simulate this and see what it's going to actually really do. I'm going to turn the toolpath off for this because there's a lot going on the screen. So as you can see, because it was an adaptive strategy at the beginning, that's the first one I picked, it left a lot of material. So I don't want to close this out yet. I want to take a closer look. It kind of leaves these stair steps. If I was to do the same process with a ball end mill, it would leave smoother stair steps. Okay, and it would actually leave these little things called cusps, which are it would leave these little things called cusps, which is where the actual ball end of the mill can't cut everything, because it's only cutting a very, very small amount of material with one of these. Okay. Either way, that's not a finishing toolpath. So when you're done with your adaptive clearing, it's not going to actually be the part that you want it to be. So we have to do something else. So what I'll do here is I'll do a 3D parallel toolpath. And for the finishing toolpaths, you definitely want a ball and mill for this. That's what these were designed for. So I'm just gonna, again, press OK and let Fusion do its thing and see what I get. Okay, that's a good start. However, the distance between these toolpaths is going to cause me an issue, and I'll show you what that issue is going to be. It's just moving over, going up and down, moving over, going up and down. And you can see it's got all these little ridges in it. This kind of looks like a, I don't know, like a tubing track or something. So I got to go back and edit some stuff. First thing I'm going to edit is my passes, my step over. That's the distance that the tool moves every time it moves in the Y direction in this case. I'm going to change that number from 0.1875 to 0.009. Okay, so really, really small amount. And what you'll see is a whole bunch of blue lines, like a really large amount of blue lines. Okay, and they are 0.009 away from each other. If I simulate this now, you almost can't tell the difference every time it cuts. And again, I would never do this moving that much material. I would always do an adaptive first. So if I speed this simulation up, what you can see is it's gonna remove the material. It's gonna take a lot longer, but you're gonna be left with a surface that's a whole lot smoother. It's not gonna have those like racetrack ridges in it. So this is kind of what I'm looking for here. So if I were to take and just simulate those two, that's how I would go about machining and making this part. I'll talk about the other one in another video. With some different 3D strategies. Okay, if I want to see what it looks like, I'm going to go ahead and turn the model off and see everything that's green was touched in the first operation, the adaptive. Everything that's blue was touched in the parallel second operation there. And I'm left, if I zoom in on that, you can kind of see there's some little tiny ridges, but those are really, really, really small and really, really, really close together. So I would be happy with this. That's how you do your first 3D toolpath.